Welcome to homework.
Chapter 14, question 26. Now they give us a combustion reaction and they're asking us about the rates. So to be able to solve this question, we need to first write the reaction expressions for each reactants and products. So as you recall, this is going to be a negative delta change of C2H4 divided by delta T. This will be equal to negative 1 over 3. We're flipping this value upside down. Delta O2 over delta T. That is equal to 1 over 2. This time, this term is positive since it's in the products. Delta CO2 over delta T. And that is equal to 1 over 2 delta concentration of H2O divided by delta T. Now, if the concentration of C2H4 is decreasing at the rate of this, so basically this, what we have over here, let me use red, this guy is 0.036. This is concentration per seconds, so the units are also agreeing with our result. What are the rates of change in the concentrations of CO2 and H2O? Now, I don't want to think about the negative sign and positive sign. Since this is decreasing at a rate, these are going to increase in the rate. So we want to find this value and this value. 0.036 equals to 1 over 2 and the increasing rate of our CO2. So 0.072 would be equal to the change of concentration of CO2 over change in time, which corresponds to our change in the concentration of CO2. And this is going to be the same exact value for the water. Delta H2O over delta T. Because these two coefficients are the exact same. The rate of decrease in N2H4 partial pressure in a closed vessel from the reaction of N2H4 plus H2 to 2NH3 is 74 torr per hour. Now they're talking about this rate in terms of pressure in torr over hour. It doesn't matter at all if even if they give us the molarity per second or torr per hour, how we are going to show the reaction expression, the rate expression, is going to be the exact same. So at this point, what we're going to do is, let's say pressure change, delta P of N2H4 divided by delta T per hour, doesn't matter at this point, but this is reducing, is going to be, since they're asking for NH3, 1 over 2 pressure change of NH3 divided by the change in time. So if this is 74 torrs per hour, then what is 1 over 2 of this guy? Let's say shortly change in pressure of NH3 divided by delta T. So the answer is going to be twice of 74, 148 torr per hour. And if they're asking about the total pressure, now we need to think how the total pressure changes. So this is 1 mole of gas and 1 mole of gas. 1 mole of gas is used and 1 mole of gas is used. They both decrease and we get 2 moles of gas. So on the left-hand side, we have -2 from the decreases, and from the increase, on the right-hand side, we have a +2. So if we add them all together, we're going to have 0 change. So the total pressure in the vessel does not change at all.